Okay, group, welcome. We're going to look at rearranging formulas. We've looked at how to solve using formulas. Here's a good example of a formula that's a little bit involved, has Celsius and Fahrenheit temperature. And tomorrow in class, we're going to be doing an activity where we're going to be taking this formula and coming up with strategies for isolating Fahrenheit if we know Celsius, and also coming up with simple ways that we can convert from Celsius to Fahrenheit using mental math. I want to just use this formula as an example that introduces inverse operations. Those are operations that undo each other or reverse each other. It's helpful to have an arrow diagram that we can use where we start with one of the variables and we're doing certain operations on that to produce the value of the other variable. A good example would be starting with a flat tire. You know, the flat tire is on the vehicle, and the first thing we do to the tire is we place the jack under the vehicle somewhere securely on the vehicle. We place the jack, then we loosen the lug nuts from the tire, then we raise the car, then we remove the lug nuts, we finally remove the flat tire, and then we reverse the process to get back to what we started with. So when we think about all these things we've done maybe on our variable f to get c, we could ask, well, what if we wanted to get back f? What if we wanted to isolate f? What would we have to do? In the changing the flat tire example, we would do everything that had been already done in reverse. We would replace the flat tire, we would tighten the lug nuts, we would lower the car, we would tighten them further, and then we would finally remove the jack from under the vehicle. So it's a very similar idea here. When we look at what's being done to Fahrenheit, first we're subtracting 32, then we're multiplying by 5, then we're dividing by 9. All those steps convert the Fahrenheit into the Celsius. If we have the Celsius and we want to get back the Fahrenheit, we would start by doing the opposite of each of these steps. And we'll look at that in class tomorrow. Okay, so just to introduce this idea of an arrow diagram, and we can think about the operations that are pairs or matching operations, an operation and its inverse. We have here addition, subtraction, multiplication, division, square and square root, cube and cube root. And I've also included a operation which is simply the value of a variable and the reciprocal of that as being inverses. And sometimes that's a useful operation to carry out, is to take the reciprocal whenever we're trying to isolate variables. So you have some strategies which are also provided here. I'm going to go through some examples here to demonstrate these strategies, that sometimes isolating the variable then substituting the numbers is more convenient than substituting the numbers and then solving, particularly if we have to substitute lots. If you have to calculate several times, it's better to isolate first and then figure out an expression that allows us to just put in numbers over and over again. If we're only having to rearrange the formula maybe once and it's a very difficult formula, it might be easier to substitute the numbers first, particularly if the numbers are easy to work with, and then rearrange afterwards. Okay? So I'm going to go through some examples here in your textbook. First one is using a formula that involves simple and compound interest, or simple interest rather. The second one is volume related to length, width, and height. We have Ohm's law formula connecting current, resistance, and voltage. So these are formulas that you may or may not have seen before. Isolating P from the simple interest formula is pretty straightforward. The only thing we're doing to P that produces the amount of the investment is adding I. So to isolate P on its own, which is the instruction here, we're going to simply take both sides of the equation and we're going to subtract I. We're going to do the opposite of addition. So it's just really a matter of identifying the operation that's performed on the variable that we're trying to isolate, and then just do the opposite of that. Okay, and we've shown this lots before throughout this course, so this is just making a little bit more formal about what the pairs of inverse operations are. So if we look at B, again to look at isolating H from that formula, Well, what's being done to h? Well, it's being multiplied by LW. You can think of it as multiplying by L and multiplying by W, but it's being multiplied by LW. So the opposite of that would be dividing by LW, and that produces h on its own. So h would be the volume divided by length times width. And the last one here, Ohm's law formula takes the voltage and it divides it by R, the resistance, to get the current I. And so to isolate voltage, we would do the opposite of dividing by R, which would be multiplying by R. And that's what's shown here. Do the same thing to both sides. That's the only thing we have to ensure is part of this process, is we're doing the same thing to both sides, and that is going to produce our value for the voltage. Example 2 has us converting from degrees to Fahrenheit. In this case, we'll do this in the investigate, so I'll skip over this one for now. We can come back to example 2 in class. Let's have a look at example 3. Solving problems involving power. So here we have the area of a circle. We have another formula which involves the volume of a sphere. And here we're being asked to isolate for the radius in part A, determine the radius, and also in part B, determine the radius. So if we look at the summary here, powers and roots are inverse operations. So to undo squaring, we take the square root. To undo cubing, we take the cube root. And we'll learn about exponent laws lots in this chapter, but in general, the inverse of the nth power is the nth root. So if we want to undo the fifth power, we would use the fifth root. So in part A, let's draw our arrow diagram here. Starting with the radius, we're squaring it, we're multiplying by pi, and that produces area equals pi r squared. If we want to isolate r, we're going to take the value of A and divide by pi, which is the opposite of multiplying by pi, and then we're going to take the square root, which is the inverse of the square operation. And then once we've done that, we can substitute in our values. So that's the easy part, substituting in the A equals 5, pi is the constant. We can solve for the radius from that. The margin notes show you how to do this on your calculator. Part B, this is the formula for the volume of a sphere, which takes the radius, cubes it. Okay, that's the exponent 3. Multiplies that by 4 pi and divides by 3. And that gives us the formula for volume, which is 4 pi r cubed all over 3. So if we want to reverse all those operations, the first thing we should do is multiply by 3. Then we would divide by 4 pi, and that would produce the value of r. And that's shown here. The final result would be that R would be 3, which is the volume that we were given in this question. And that's substituted at the beginning. So that strategy of substitute and then solve is shown here. So take the volume, divide by 4 pi, take the cube root, and we get radius, which is approximately 0.62 meters. Let's go back to your handout. This page here has some strategies, but it also has just a summary now of what we've seen in this lesson, which is that certain operations can be reversed or undone by other operations, and there's a goal involved in each. So I want to go and fill this information in for you. At this point, addition, you've seen subtraction paired with that, so subtraction and addition undo each other. The goal when we're adding or subtracting in an equation where a formula is involved is to produce 0 as a term. I'm going to give an example of that. If we were to go to a simple equation such as x plus 3 equals 7, we know the answer is x equals 4. And we arrive at that by reducing both sides by 3. We don't want x plus 3, we want x. So we're going to reduce x plus 3 by 3, and we're going to reduce 7 by 3. And in doing so, we're really just adding 0 to x, which gives the value of x. Okay, so producing 0 as a term works for addition or subtraction. If this were subtraction, we would have added. And in that case, we would still end up with x plus 0, because negative 3 plus 3 is 0. and we would have ended up with, instead of 7 subtract 3, we would have ended up with 10. And that makes sense because 10 subtract 3 is 7. Let's go back here and look at multiplication and division. Multiplication and division, the goal whenever we use those pairs of operations to undo each other will be to produce 1 as a factor. Example to show here, where we have something such as 3x equals 21. Again, we know the answer is 7 from inspection here. We can get our answer by dividing both sides by 3, and in doing so, we produce 1 as a factor. We don't want 3 x's, we want 1. The value of 1x, obviously we've isolated the variable. So in that case, dividing undoes multiplication. If we started with x divided by 3 equals, let's say, 21, there, again, we don't want, we can think of this as a third multiplied by x equals 21. That would be the same as dividing by 3. Again, we don't want a third of x, we want 1x. So if we were to triple both sides, either think of it as tripling x over 3, or think of it as tripling 1/3. In both cases, we're going to produce 1 as a factor. 3/3 is 1, and 3 times x divided by 3 is the same thing as 1x, which would be 63. Okay, so multiplication and division, the goal is to produce 1 as a factor, so we can always be looking for that. Squaring and cubing are exponents, and their inverses are square root and cube root. And there are other options we could explore, but generally, whatever the exponent is, we want to do the root of the value. The goal there is to produce 1 as an exponent. If we go to our example page here and look at something such as x squared equals 9, again there, we have currently an exponent of 2 on x. Well, we want x. X has an exponent of 1. So our final answer has to be x to the 1. So how do we produce an exponent of 1? Well, when we take the square root of both sides, the square root of x squared produces an exponent of 1. It produces x. Root of 9 and be 3. If we were, on the other hand, working with maybe the cube of x, if the cube of x were, let's suppose it was 64, use a whole number there. We know that 4 cubed is 64, so there we take the cube root of x cubed, which produces x to the 1, which would be 4. Okay, if we go the other way, and we were starting with, let's say, the square root of x equals 100, well, squaring both sides converts us from square root back to an exponent of 1. So in either case, root and exponent undo each other. In that case, we would get 10,000. Okay, so that has us understanding why we perform the operation, what the goal is. And the last one I'll just point out is that when we have a value, the inverse of a value is the reciprocal of the value. And the goal there, why we might want to do that, is to move the position of the variable. To give you one more example here, sometimes we have the unknown in the denominator. Let's suppose it was 3 over x equals 30. In that case, cross multiplying would be one strategy. Another strategy would be to reciprocate. Reciprocating in fractions is moving the position of the numerator and the denominator. So the reciprocal of 30 is 1/30. So these are also reciprocals. So we reciprocate the left side, we reciprocate the right side. And then after that, we can use multiplication as a strategy. So 3 is our multiple. That will undo division. It will also produce a factor of 1. And we know that 3 times x over 3 is 1x. There's our multiple of 1, or a factor of 1. We're not trying to produce 0 as a term. We don't have anything added to the variable, so we don't have to worry about undoing addition or subtraction. And 3 times the 30th would be 1/10 or zero point 0.1, which is what we'd expect because if we divide 3 by 0.1, we get 30. So that can be our check. So again, there, moving the position of the variable is convenient to do when we have our unknown in the denominator. Just a few tips to add to your lesson notes here. First tip is when you're isolating a variable, perform opposite operations. But perform opposite operations in the opposite order of bed mass. You'll find that whenever you have multiple operations involved, you will want to peel off the layers, if you think of it that way, by starting with subtraction and addition, and then moving from there to division, multiplication, and then finally moving to exponents, and then finally brackets. Okay. Tip 2 is make sure you perform opposite operations on both sides. If you don't, you're going to make an error. And the third tip is, since I've introduced the reason why each of these strategies work, look for 0 as a term, 1 as a factor, or 1 as an exponent on our variable after each step. And that will ensure that you have done the correct operation. If you find that your operation doesn't produce one of those outcomes, then you've done something wrong. Okay? So the assigned questions for this section will just be working with a partner, looking through some questions on page 354, and then some pairs to look at as well after that. And I'm looking to collect 14 or 16 on either page 356 or 357. We'll see you tomorrow.